Last slide. I should start from here. Yesterday we were doing till here. Read this. Ankit Ningru. From the beginning. Jor.
Resistance of a conductor depends on its length, its area, cross section, and nature of material.
Okay, so actually we have studied that resistance. Resistance means opposing force. Resistance means opposing force. So this opposing force is totally dependent on three things. One is length. If the length of the wire is too much long and the current is too much minimum current, if I give to this long what metal circuit, will the current pass from that? No. Okay, so its length. Second, cross section area, its thickness. Cross section area, it shouldn't be too much big. Either if it's too much big, we should give more current. Last, nature of material. Material should be copper. Okay, slow metals is not. If you use aluminum, depending on the metal, which metal you are using. If you use aluminum, it will go less, current will be less. If you use copper, it's very good. Correct? So depending upon which metal you are using, the current will pass very faster or slower. Getting the resistance will be either too much high or too much low based on the metal. So these are the three factors, including variable resistance. Next.
Resistance of a uniform metallic conductor directly proportional to its length. R is proportional to I. And inversely proportional to the area of cross section. R is directly proportional to.
Resistance of a uniform metallic conductor is directly proportional to its length. So we just understood that resistance is directly proportional to length. How much length will be higher, that much resistance will be high. If length is too much high, length bar resistance will be increasing. It will give more resistance. If length is low, wire, very small wire, then resistance will be less. Just resistance current will pass easily. Getting? So resistance is directly proportional to length, but it's inversely proportional to read. And inversely proportional to the area of cross section area. So it's 1 by A. 1 by A means L by A, but resistance is inversely proportional. If resistance is high, area of area of cross section will be low. If resistance is low, area of cross section will be high. Resistance is directly proportional to length, whereas resistance is inversely proportional to the area of cross section. Getting? Any doubts? Okay, next. So we get a formula: rho is equal, R is proportional to L by A. R is equal to rho means resistivity, length upon area. Length upon area. Next. Rho. This is called as rho. 30 point. ನಿಂದು ಭಾಳ ಇದನ್ನಾಗತ್ತಿತ್ತು ಪಾ ನಿಂದು ಹೇಳಾಕ ಬರ್ಬೋದು ಅದಕ್ಕೆ ನಿಂಗೆ ಬೇಡ ಅದನ್ನ ಟು ಮಚ್ ಅಂದ್ರೆ ಭಾಳ ಜೋರು ಓದ್ತೀನಿ ಸರ್ ಮೇಲೆ ಕೆಳಗೆ ಒಂದು ಫ್ರೀಕ್ವೆಂಟ್ ಬರ್ಬೋದು ನಂಗೆ ತಿಳಿಯಂಗಿಲ್ಲ ಅದು ರೀಡ್ ದಿಸ್ ಜರಾ ಜೋರ್ ಅಜುನಿದ ವಾಚ
P is the
rho.
Where rho is a constant of proportionality and is called electrical resistivity.
So this rho is called as electrical resistivity. Electrical resistivity.
Of the material of conductor.
Of the material of the conductor. Now each and every material has its different resistivity. We were discussing this. So the material resistivity is called as rho. ಈಗ ನಾ ಮೆಟಲ್ ಐರನ್ ತಗೊಂಡೆಪ್ಪ Fe, its resistivity is called as rho, and rho changes for every metal. For iron it's different, rho resistivity will be different. For copper this rho will be different. For aluminum this rho will be different. For gold Au this rho will be different. For silver it will be different. Getting? Rho means resistivity. Resistivity depends upon the metal. For every metal, resistivity will change. Correct? So rho R is equal to rho length. How much is the length of that aluminum wire? How much is the length of that gold wire? That is length. And area. Area means just the pipe cross section area. How much is the thickness? How much is the width of that? Getting? So rho is a constant of a proportionality and is called electrical resistivity of the material of conductor. It is a characteristic property of the material. It is a characteristic property of material. That means how much that material can possess its resistivity. That's called as rho. Any doubts? Any doubt? Okay, next. SI unit of resistivity is, so SI unit of resistivity is ohm. We write it as ohm. 5 ohm, 2 ohm, 3 ohm. Resistivity is written in ohm. Any doubts? Any doubts in resistivity? Okay, read it once again. So first we understood there are three things which factor resistance. One is its length. If length is too much high, the resistance will be low. Second one is area of cross section and nature of material. Next, rho will be different for each and every metal. So it's a constant truth. If you take iron, all iron will have same resistivity or no? All copper will have same resistivity. All aluminum will have same resistivity, almost same. Getting? So rho means it's a resistivity constant which varies by temperature. Okay. Any doubts still here? Any doubts? Okay, next. Read.
Resistivity of metals and alloys is very low. 10 to the power of minus 8 to 10 to the power of minus.
Correct. So only we use metals. Resistivity of metals and alloys. Alloys means example aluminum alloys ಅಂದ್ರೆ ಅದು ಪ್ಯೂರ್ ಫಾರ್ಮ್ ಆಫ್ ಸಿಕ್ಕಿರ್ತದೆ ಆ ಟೈಪ್ ಅದು ದಟ್ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇನ್ ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ ಫರ್ದರ್ ಚಾಪ್ಟರ್ ಸೊ ಜಸ್ಟ್ ಮೇಲೆ ತಿಳ್ಕೊರಿ ಸೊ ರೆಸಿಸ್ಟಿವಿಟಿ ಆಫ್ ಮೆಟಲ್ಸ್ ಅಂಡ್ ಅಲಾಯ್ಸ್ ಇಸ್ ವೆರಿ ವೆರಿ ಲೋ getting or so only we use metals and alloys to pass current getting very low such as 10 power minus 8 see 10 power minus 8 and just ಕಮ್ಮಿ ಆಯ್ತು ವಿಚಾರ ಮಾಡ್ರಿ current will pass easily or no the flowing of current will be very easy because the resistivity is very low. They are good conductors of electricity definitely. All the metals, all the alloys ಅಂದ್ರೆ ಏನಪ್ಪ ಎರಡು ಮೆಟಲ್ ತಗೊಂಡು ನಾನು ಜಾಯಿನ್ ಮಾಡಿ ಹೊಸದು ಹುಡುಕಿದೆಪ್ಪ that's only alloy. Two metals if I take, mix them, and if I get steel is an alloy. Getting? Can you get directly steel ಸಿಗ್ತದೇನೆ ಅಂದ್ರೆ ಈಗ ನಾ ಏನ್ರಿ ಎಲ್ಲರ ಕಡ್ಡ ತೆಗೆದಪ್ಪ can I get steel? You can get metal, you can get iron, you can get different things, gold, but steel you can't get. Steel is made in laboratories. That's an alloy. Adrallo current pass agate. So metals and alloys have very low resistivity and they are good conductors of water, electricity. Next.
Resistivity of insulators like rubber, glass, etc. is very high.
So if you take insulators means ulta. If you take rubber, if you take glass, can you pass current in that? Can you pass current in this glass? Can you pass current in this glass? Impossible. ಹೋಗಂಗಿಲ್ಲ current. Fiber, if getting or no, in all these things we cannot pass current. So resistivity of insulators, example rubber, glass, is very high, 10 power 12 to 10 power 17 ohm per meter. So if you pass current, it will not pass only. Resistivity ಸಿಕ್ಕಾಪಟ್ಟೆ high ಇರ್ತದೆ. Whereas in metals and alloys, resistivity is low. Okay, next.
Resistance and resistivity vary with temperature.
So with the temperature, ಈಗ ಸಿಕ್ಕಾಪಟ್ಟೆ heat ಮಾಡಿದ್ವಿಪ್ಪ ನಾವು metal alloy, current will pass easily or slowly? Think. If I heat a metal alloy, current will pass easily or slowly? According to you guys, ಏನಾಗ್ತೈತೆ heat ಮಾಡಿದ್ರೆ metal alloy? It will pass faster because the atoms will get looser. The atoms are tightly packed in solids. When we heat that, they will become loose. So when I pass current, it will fast with the current. But that only if we cool them. As fast as current, tightly packed up. So with the temperature, if I increase the temperature, current will pass. If we decrease the temperature, current will not pass. Getting? Next.
Resistivity of an alloy is generally higher than that of its constituent metal. Alloys do not oxidize or burn readily at high temperatures, so they are used in electrical heating devices like electric iron toasters, etc.
Read that once again.
Resistivity of an alloy is generally higher than that of its constituent
See here.
metals.
Constituent metal means directly iron. Now you have used that toast maker. Toast maker, if you press that, 5 minutes toast ready ಆಗ್ತದೆ. Okay. Or if you use istri ಮಾಡೋದು. Okay, iron. If you use iron, do you guys think they are using iron there? They are using iron, Fe metal. Fe metal they are using? No. They are using steel, stainless steel. ಬೇರೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ. No one will use, even ನೀವು ಬೇಕಾದ್ರೆ ಇದಂತೂ ಬರೀ ತವಾ ಆಗಿವ ಸ್ಟೇನ್ಲೆಸ್ ಸ್ಟೀಲ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಗೊತ್ತಿರ್ಬೇಕು ನಿಮಗೆ ಸ್ಟೇನ್ಲೆಸ್ ಸ್ಟೀಲ್ ಅಂತ ಹೇಳ್ತಾರೆ. If you use any tawa for dosa, any of that, no one will use directly iron. If you use iron, it can get very very fast. Iron in the heating capacity of iron under heat jaldi agi iron, there is a chance of losing its originality and jaldi idana agbiduತ್ತೆ, heat start agbiduತ್ತೆ. But whereas the constituent metals such as alloy is made up of iron and 2 other things. Mix ಮಾಡಿದ್ರೆ alloy ಬರ್ತದೆ. alloy ನ ಕಿಂತ ಜಾಸ್ತಿ ದಿನ ಬರ್ತದೆ, ಏನೂ ಆಗಿಲ್ಲ, heat ತಡ್ಕೋತದೆ. There is a capacity of holding heat. Alloys have a capacity of holding heat like this, you can think. They have a capacity to hold heat higher temperature. Getting ನೀವು ಎಷ್ಟು ಹೈ ಟೆಂಪರೇಚರ್ ಮಾಡಿದ್ರು ಮತ್ತೆ ಆಸ್ ಇಟ್ ಇಸ್ ಸೇಮ್ ಇರ್ತದೆ, ಅದೇನು ಬರ್ನ್ ಆಗಿದ್ದೇನೋ ತಿಳಿಯಂಗಿಲ್ಲ ಆ ಪರಿ. ಸೊ ರೆಸಿಸ್ಟಿವಿಟಿ ಆಫ್ ಅನ್ ಅಲಾಯ್ ಇಸ್ ಜನರಲಿ ಹೈಯರ್. Alloy's resistivity is higher. Resistivity of alloy is higher, whereas this resistivity is what? Very very low. Heating capacity iranilla, it's very very low. Resistivity of alloy is higher than resistivity of own metal. This is iron benches, what you are sitting, that's iron. Other resistivity ಜಾಸ್ತಿ ಇರಂಗಿಲ್ಲ. ಈಗ ನಾ ತಂದಿಲ್ಲ ಏನ್ರ ಬೆಂಕಿ ಜೋರ್ ಹಚ್ಚಿದ್ರೆ ಬರ್ನ್ ಆಗಿ ಮೆಲ್ಟ್ ಆಗ್ಬಿಡ್ತೈತೆ. Getting, but alloy to melt that it's very very tough. Alloy jaldi melt ಆಗಂಗಿಲ್ಲ, ಭಾಳ heat ಕೊಡ್ಬೇಕು. Getting that? Alloy requires more heat to burn or melt, but whereas the metal requires less heat. It can burn, it can melt very easily. That they are saying here. Read it once again.
Resistivity of an alloy is generally higher than that of its constituent metals.
So here in bread toaster, or here this is tungsten. Okay, ಇಲ್ಲೆಲ್ಲ ಏನು ಯೂಸ್ ಮಾಡ್ತಾರೆ? They are using what? Alloys. They are not using metals there. If you use metals, ಸಿಕ್ಕಾಪಟ್ಟೆ ಬಂದ್ರೆ ಬರ್ನ್ ಆಗೋ ಚಾನ್ಸ್ ಇದೆ, ಇಲ್ಲ ಬ್ಲಾಸ್ಟ್ ಆಗೋ ಚಾನ್ಸ್ ಇದೆ. So they don't use metals, they use what? Alloys there, because their resistivity is higher. Next.
Tungsten is used for filaments.
I was.
Alloys do not oxidize or burn readily at high temperatures.
So at high temperatures they don't burn or they don't melt. ಈಗ ನೀವು ಇಸ್ತ್ರಿ ಮಾಡತ್ತಿರ್ಪ ಮೆಟಲ್ ಮಾಡಿದ್ರೆ ಮೆಲ್ಟ್ ಆಗ್ಬಿಡ್ತಿತ್ತು, ಜಾಸ್ತಿ ಹೀಟ್ ಕೊಟ್ರೆ ಮೆಟಲ್ ವುಡ್ ಮೆಲ್ಟ್. ಗೆಟಿಂಗ್, ಬಟ್ ಇಫ್ ಯು ಯೂಸ್ ಅಲಾಯ್, ಯಾವಾಗ ಮೆಲ್ಟ್ ಆಗಿ ನೋಡ್ರಿ ನೀವು? ನೋ, ಬಿಕಾಸ್ ದೇ ಆರ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ಅಲಾಯ್ಸ್, ದೇ ಹ್ಯಾವ್ ಹೈ ರೆಸಿಸ್ಟಿವಿಟಿ. ಓಕೆ, ಸೊ ಅಲಾಯ್ಸ್ ಡು ನಾಟ್ ಆಕ್ಸಿಡೈಸ್. ಆಕ್ಸಿಡೇಷನ್ ರಿಯಾಕ್ಷನ್ ಓದಿ, when a metal or anything gets mixed with oxygen, burning start occur. So alloys do not oxidize, burn readily at high temperatures. They don't burn at high temperatures, they remain as it is. They just provide heat. So they are used in electrical heating devices like electric iron, toasters, etc. or tungsten. So they are all made up of what? Alloys. ಈಗ ಅದು ಸ್ಟಾರ್ಟ್ ಆಗೈತಿ, ಅದ್ರ ಒಳಗಡೆ ಎಷ್ಟು ಹೀಟ್ ಇರ್ತದೆ ನಿಮ್ಗೆ ಐಡಿಯಾನೂ ಇಲ್ಲ. ಜಸ್ಟ್ 2 minutes ನಾ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ರೆ ಅಲ್ಲಿ ಟಚ್ ಮಾಡಕ್ ಬರಂಗಿಲ್ಲ. ಒಂದ್ಸಲ ನಾ ತೆಗೆದು ನೋಡಿದೆ, ಲಾಸ್ಟ್ ಇಯರ್ ಹೊರಗೆ ತೊಗೊಂಡು ಹೋಗಿದ್ದಾರೆ. ಬರೀ 1 minute if you start that much heat it will produce. But I use it for 1 hour, 1.5 hours, sometimes 2-3 hours. But also that will not burn. Why it is not burning? Because it is made up of alloy. ಅದು ಹಿಡಿದು ನೋಡ್ರಿ ಯಾರು ಗೊತ್ತಾಗ್ತೈತಿ ಪರಿಸ್ಥಿತಿ, ಅದು ಎಷ್ಟು ಹೀಟ್ ಆಗಿರುತ್ತೆ ಅಂತ ಹೇಳಿ. ಗೆಟಿಂಗ್ ಅವ್ರನ್ನ, ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ಅಲಾಯ್, ಇಟ್ಸ್ ಸ್ಟಿಲ್ ಅಲೈವ್. ಅದೇನ್ರಿ ಮೆಟಲ್ ಮಾಡಿದ್ರು ಬರ್ನ್ ಆಗ್ಬಿಡ್ತಿತ್ತು, ತೆಳಗ್ ಬಿಡ್ತಿತ್ತು ಮೆಲ್ಟ್ ಆಗಿ. ಗೆಟಿಂಗ್, ರೀಡ್ ನೆಕ್ಸ್ಟ್.
Tungsten is used for filaments of electric bulbs.
So tungsten is used for filaments of electric bulbs.
Copper and aluminum are used for electric transmission lines.
So copper or aluminum. Whatever electrical transmission lines, ಈ ದೊಡ್ಡ ದೊಡ್ಡ ವೈರ್ ಕಾಣಿಸ್ತಾವ ನೋಡಿ, ಊರ್ ಹೊರಗೆ ಹೋದ್ರೆ ವಿಲ್ ಸಿ ದಿಸ್, ಊರಿಗೆ ಬರ್ತಿರ್ತಾವ. Getting? So these are made up of copper and aluminum. Why they are made up of copper and aluminum? Because first point, it will travel faster, current will travel faster, and very less amount of current is wasted there. ಈಗ ನಾವು ಒಂದು ಸ್ಟೇಟ್ಲಿ ಇನ್ನೊಂದು ಸ್ಟೇಟಿಗೆ ಕರೆಂಟ್ ಕಳ್ಸಾತೇನಪ್ಪ, ಈಗ ಬೇರೆ ಕಂಟ್ರೀಸ್ ಟು ಕಂಟ್ರಿ ಕರೆಂಟ್ ಹೊಂಟೈತೆ. ಅದಾನಿ ಈಸ್ ಮೇಕಿಂಗ್ ದಟ್, ಈ ಕಂಟ್ರಿಲೇ ಬೇರೆ ಕಂಟ್ರಿ ಕಳ್ಸಾತಾನ. ಸೊ ಇಲ್ಲಿಂದ ಇಲ್ಲ ಅಲ್ಲೇ ರೆಡಿ ಆಗ್ಬೋದು, ನಂಗೆ ಸ್ಟಡಿ ಇಲ್ಲ. ಈಗ one state to another state or one city to another city, if they are transferring that current, if too much of wastage is happening of current, what will happen? Correct? The current shouldn't be wasted. ಇಲ್ಲ 100 ವ್ಯಾಟ್ ರೆಡಿ ಮಾಡಿದ್ರೆ 100 ವ್ಯಾಟ್ ಹೋಗ್ಬೇಕಲ್ಲ. Getting? ಅಷ್ಟು ಕರೆಂಟ್ ಹೋಗ್ಬೇಕಲ್ಲ. That I'm saying. So it is made up of copper and aluminum. Any doubts? Okay, next. Read this once again.
Tungsten is used for filaments of electric bulbs.
So whatever electric bulbs you see, ಈಗ ಇದು ಯಾರು ಯೂಸ್ ಮಾಡಿಲ್ಲ, ಇದೆಲ್ಲ ಹೋಗ್ತೀವಿ, ಈಗೆಲ್ಲ LED ಬಂದವು. ಸೊ ಮೊದ್ಲಿನ ಕಾಲಕ್ಕೆ ಯೂಸ್ ಮಾಡಿದೆ ಅಂತ ನೋಡಿರ್ಬೇಕು ನೀವು, ಎಲ್ಲೋ ಬಲ್ಬ್ಸ್. ಸೊ ಅದ್ರೊಳಗೆ ಟಂಗ್ಸ್ಟನ್ ಅಂತ ಇರ್ತದೆ. ಅದು ಒಂದಿನ ಹಚ್ಚಿ ನೋಡ್ರಿ ಎಷ್ಟು ಬಿಸಿ ಆಗಿರ್ತದೆ ನೋಡ್ರಿ. ಒಂದಿನ ಯಾರು ಹಚ್ಚಿ ಹೋಗ್ಬಿಟ್ರಿಪ್ಪ, ನೆನಪಾರಿದ್ರೆ ಫುಲ್ ಹೀಟ್ ಆಗಿರ್ತದೆ ಟಂಗ್ಸ್ಟನ್. So that 24 hours, 36 hours, if you use also continuous, nothing will happen. It will hold the heat because it is made up of tungsten. ಅದು ಬಿಟ್ಟು ನೀವು ಏನಾರ ಬ್ಯಾರೆದ್ ಹಾಕಿದ್ರೆ ಅಂದ್ರೆ ಬರ್ನ್ ಆಗ್ಬಿಡ್ತಿತ್ತು. Getting? So tungsten also can hold heat to the largest extent. ಮತ್ತೆ ಇಷ್ಟ ತೆಳ್ಳಂಗಿರ್ತದೆ, ಜಾಸ್ತಿ ಇದನ್ನ ಇರಂಗಿಲ್ಲ, ಇಷ್ಟ ಇರ್ತದೆ ವೈರ್, ಆದ್ರೂ ಬರ್ನ್ ಆಗಿಲ್ಲ. Getting? So because it is made up of alloy, it has high resistivity. Any doubts about resistivity topic? What did we learn here? We learned that alloys hold high resistivity. They will not burn easily. Okay. Next, metals. Whereas metals can burn easily or melt out. There is a problem with metals. But whereas if you use alloys, it's better. Example for toaster and iron. And tungsten is used as a filament in bulbs. And lastly, copper and aluminum used in what? Transferring the transferring of electricity through the electrical poles. Any doubts? Any doubts? Okay, next. So here we have different resistivity according to metals. So conductors, alloys, insulators. 3 varieties are there. Conductors means where current can be passed very easily, and it's made up of metals. Alloys means you have to mix ಮಾಡಿ ಇದು ಬಂದಿರ್ತೈತಿ, They are mixing metals, you will get one different thing. That is called as alloy. And lastly, insulators. Insulator current pass ಆಗಿಲ್ಲ, where current cannot be passed. So silver has a resistivity of 1.6 into 10 power minus 8. ಅಂದ್ರೆ ಬಹಳ ಕಮ್ಮಿ ಅದು, very slow. Next, copper ಅಂತೂ 1.62 into 10 power minus 8. So current will pass very easily. Aluminum 2.63 into 10 power minus 8. Still more easier to pass. Aluminum. Like this, these are the things. Nickel, you can see tungsten 5.20, nickel 6.84. Getting? Next, if I take alloys, constantan 49 into 10 power minus 6. Manganese, it's made up of copper, manganese, nickel. They are using 3 metals. Combine them, you will get what? Manganese 44 into 10 power minus 6. Nichrome, nickel, chromium, manganese, iron. Ella mix ಮಾಡಿದ್ರೆ you will get nichrome 100 into 10 power minus 6. So these are made by human beings. ಇದಿಲ್ಲ ಜಗತ್ತೊಳಗೆ, directly you can't get this. But their usage is too much. ಬೇರೆ ಯೂಸ್ ಹಾಕೋ ಹೇಳಿಲ್ಲ ಸದ್ಯಕ್ಕೆ. Last, insulators, glass 10 power 10 into 10 power 14. Paper 10 power 12. Diamond 10 power 12 to 10 power 13. Hard rubber 10 power 13 to 10 power 16. Ebonite 10 power 15 to 10 power 17. So that much resistivity high ಇರ್ತದೆ. Pass ಆಗಂಗಿಲ್ಲ, current cannot pass. Very tough. Very tough. Alloys ಆರಾಮ್ ಪಾಸ್ ಆಗತ್ತೆ current. And it has high resistivity. ನೋಡ್ರಿ resistivity ನೋಡ್ರಿ ಹೆಂಗಿದೆ, 49 ಇದೆ, 4 ಇಲ್ಲ 6 ಇಲ್ಲ, 49 into 10 power minus 6. Think how much resistivity low is it. So if you pass current instant, it will pass. ಗೆಟಿಂಗ್. ಆಮೇಲೆ ಹೀಟ್ ಸಿಕ್ಕಾಪಟ್ಟೆ ಹೋಲ್ಡ್ ಮಾಡ್ತೈತಿ, ಬರ್ನ್ ಆಗಂಗಿಲ್ಲ, ಮೆಲ್ಟ್ ಆಗಂಗಿಲ್ಲ ಮೆಟಲ್, ಅಷ್ಟು ಚಲೋ ಇರ್ತದೆ ಬಟ್ ಅಲಾಯ್. ಲಾಸ್ಟ್ ವಿಲ್ ಕಮ್ ಮೆಟಲ್ಸ್. ದೀಸ್ ಆರ್ ಆಲ್ ಮೆಟಲ್ಸ್. These are all metals: silver, copper, aluminum, tungsten, nickel. Okay, so these conductors are metals, and here there is a less water. Resistivity is also less, and the temperature is also. ನೀವು ಜಾಸ್ತಿ ರೇಸ್ ಮಾಡಿದ್ರೆ ಬರ್ನ್ ಆಗೋ ಚಾನ್ಸ್ ಇರ್ತಾವೆ, ಇಲ್ಲ ಮೆಲ್ಟ್ ಆಗೋ ಚಾನ್ಸ್ ಇರ್ತದೆ. ಎಸ್ ಅವರು ಮೆಲ್ಟ್ ಆಗ್ಬಿಡ್ತೈತೆ ವೈರ್ಗೆ. ಈಗ ಅದು ಫ್ಯೂಸ್, ಕ್ಯಾನ್ ಯು ಸಿ ದ ಫ್ಯೂಸ್? ಅಲ್ಲಿ ಕಾಣತ್ತೆ ಫ್ಯೂಸ್ ಅಲ್ಲೈದು ನೋಡಿ, ಒಂದು ರೆಡ್ ಕಲರ್, ಒಂದು ಬ್ಲೂ ಕಲರ್. That is there in the further topic. So ಜಾಸ್ತಿ ಏನ್ರ ಕರೆಂಟ್ ಫ್ಲೋ ಆತಂದ್ರೆ 220 ವೋಲ್ಟ್ ಮೇಲೆ ಒಂದ್ಸಲ ಫ್ಲೋ ಆತಂದ್ರೆ that will initially burn, ಸುಟ್ಕೊಂಡ್ಬಿಡ್ತದೆ. So what will happen if that burns? The circuit will break. So nothing will happen to these devices. ಇದಕ್ಕಾತ ಏನೂ ಆಗಿಲ್ಲ. ಫ್ರಿಜ್ ಆತ ಮನೆ ಒಳಗೆ, ಟಿವಿ ಆತ ಗೆಟಿಂಗ್. ಸೊ ಬರ್ನ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರ್ತಾವೆ, ಅವ್ರು ನಾವು ನೋಡಿರಂಗಿಲ್ಲ ಅಷ್ಟೇ. ಸೊ ಮೆಟಲ್ಸ್ ಯೂಶ್ವಲಿ ಬರ್ನ್ ಇಫ್ ದೇರ್ ಇಸ್ ಅ ಟೂ ಮಚ್ ಪಾಸಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ. ಜಾಸ್ತಿ ಪಾಸ್ ಆತ ಬರ್ನ್ ಆಗ್ಬಿಡ್ತದೆ. Okay, that they are teaching us here. Any doubts? Any doubts in metals, alloys, conductors, insulators? Any word you have doubt? Any doubt? Take it. Next. So this is part 2. Okay, read.
Resistance of a system of resistors.
Okay, so there are resistance of a system of resistors. So till now we have studied about resistors. Okay, what is the work of resistors? Okay. So resistance will oppose the flow of current. If current is passing, they will oppose that. So to adjust these resistors, we have two types. First one is series. Second one is parallel. There are two types of connections we can make. Now by using resistors, there are two types of connections. One is series, one more is parallel. These are the two connections which we have. Okay, example, series means you can see here, first this is first resistance, second resistance, third resistance. It is connected here, it is connected here, it is connected here. This is in series or no? Series, it is going in a series. Whereas here you can see it is parallel. R1 is parallel to R2, is parallel to R3. The three are going parallelly. Here they are going in series. So there are different uses of this. There are different uses of this circuit. There are different pros, cons. Similarly, pros, cons. Useful hodavo, upayogillado hodavo. So we'll understand when to use which circuit and what are its benefits, what are its disadvantages. That we'll study here. Any doubts? Okay, read this.
In electrical gadgets, resistors are used in various combinations based on Ohm's law. There are two methods of joining the resistors: resistors in series and resistors in parallel.
So there are two connections we can make. One is resistance in series, one is resistance in parallel. Okay, next. Read.
Join the resistors having resistance.
Now we are seeing series resistance. Okay, they are telling us about series. What will happen in series? That they are saying. Okay, read.
Join three resistors having resistances R1, R2, and R3. Example: 1 ohm, 2 ohm, 3 ohm in series. Connect them with the 6V battery and ammeter and the plug in both that ammeter reading. Change the position of ammeter in between the resistor of the value is same.
Okay, see here. So this is the ammeter. What is the work of ammeter? What's the work of ammeter? Ammeter shows what? which measures current. Okay, just slow it down, Divani. It's an instrument which measures current. It will measure current. Voltmeter will measure potential difference. Okay, so read it from the beginning.
Drawing the resistors having resistances
See, we are connecting three resistors R1, R2, R2. Next page. Next page. Okay, stop writing now. So here they have connected first resistance, second resistance, third resistance in series. This is the ammeter. This is the connection. Okay, what will happen here? That they are saying. Read from here.
connect them with a 6 volts battery.
So the battery is connected here. It is 6 volts.
An ammeter and the plug key. Note the ammeter reading. Change the position of ammeter in between the resistors. The value is same.
So first time we have kept ammeter here. Okay, think that it is producing some 5 ampere of current. Okay, 5 ampere of current. Now if I switch it and keep ammeter here, here also will find how much? 5 ampere. If you keep it here, here also will find 5 ampere. If you keep it here, if you connect it like this, hing connect ಮಾಡಿ ಇಲ್ಲಿ ammeter ಇಟ್ರಿಪ್ಪ. Here also will find how much? 5 ampere. So series resistance tells us that the current flow will never change. Here 6 volts battery if you connect, whatever the current is flowing through resistance R1, R2, R3, the current flow will never change. 5 ampere ಇತ್ತಂದ್ರೆ ಇಲ್ಲಿಂದು 5 ampere ಇರ್ತೈತಿ, ಇಲ್ಲೂ 5 ampere, 5 ampere, 5 ampere, 5 ampere, wherever you keep, will find the same water current flowing through the circuit. Throughout the circuit, same current will flow. Now what is the demerit of the same current flow? Any idea about you guys that you think? Change of current is not happening. Everywhere same current is passing. What are the demerits that might happen? Now think, this projector is there. Here one sun bulb is harbited. Here one small bulb is there. That needs 120 ampere of current. Okay, but this needs only 2 ampere of current. For that, if it gets 20 ampere, it will work. For this, if I leave 20 ampere, what will happen to the bulb? Burst up. Getting or no? So only we don't do series. Now whatever here you are saying, it's all connected parallelly. Parallel, what it will do means, how much ಎಷ್ಟು ಬೇಕಲ್ಲ ಅಷ್ಟೇ ಕೊಡ್ತಿರ್ತದೆ. ಎಲ್ಲ ಕಡೆ ಚೇಂಜ್ ಇರ್ತದೆ. ಇಲ್ಲಿ ಇದಕ್ಕೆ ಒಂದು ಸಿಕ್ಕಾತೈತೆ ಅಂದ್ರೆ ಇದಕ್ಕೆ ಒಂದು ಸಿಕ್ತಿರ್ತೈತೆ. ಗೆಟಿಂಗ್ ದಟ್ CCTV ಬೇರೆ ಸಿಕ್ತಿರ್ತದೆ, ಇದಕ್ಕೆ ಬೇರೆ ಸಿಕ್ತಿರ್ತದೆ, ಇದಕ್ಕೆ ಬೇರೆ ಸಿಕ್ತಿರ್ತದೆ, ಅದಕ್ಕೆ ಬೇರೆ ಸಿಕ್ತಿರ್ತದೆ. ಎವ್ರಿವೇರ್ ದ ಕರೆಂಟ್ ಇಸ್ ಡಿಫರೆಂಟ್. ಗೆಟಿಂಗ್ ಇಟ್ಸ್ ನಾಟ್ ಪಾಸಿಂಗ್ ಅಟ್ ದ ಸೇಮ್. ಗೆಟಿಂಗ್ ಯಾತೈತಿ ಅದು ಮುಂದೆ ತಿಳಿತೈತೆ ನಿಮ್ಗೆ ಜಾಸ್ತಿ. So one thing you can think is that the current will stay same throughout the circuit. It will not change. If 5 ampere of current you are leaving, throughout the circuit you will observe 5 ampere. Any doubts in series? Next. Read. Read.
In a series combination of resistors, the current is the same in every part of the circuit or the same current through each resistor.
This is the main point you should take. In a series circuit, the current is same throughout the circuit. All the resistors you take, wherever you want to keep, everywhere the passing of current will be 5 ampere. ಈಗ ಇಲ್ಲಿ 5 ampere ಪಾಸ್ ಆತ ರೆಸಿಸ್ಟೆನ್ಸ್ 1 ಒಳಗೆ, ಇಲ್ಲಿ ಬಂದು ಕಮ್ಮಿ ಆಗಿ 4 ampere, ಇಲ್ಲಿ ಬಂದು ಕಮ್ಮಿ ಆಗಿ 3 ಆಗಿಲ್ಲ, ಫರಕ್ ಬೀಳಂಗಿಲ್ಲ ಅದು. You keep 10 resistors here. Through all the 10 resistors also, 5 ampere of current will only flow. Getting that they're saying. Even through the resistors, the current will not flow. The current will flow at the same pace. It will not change. Any doubts? Okay, next page. Don't write now. Just listen. Next. ಈಗ ಬರ್ಕೊಂಡ ಮಲ್ಲಾಗಿರೋದು. Right. Read.
Insert a voltmeter across the ends X and Y of the series. Combination of 3 resistors. Note that potential difference. Now measure the potential difference across the 2 terminals of the battery. Compare these values. Now measure the potential difference V1, V2 and V3 across the first, second and third resistors separately. the total potentials difference V across a combination of resistors in series is equal to the sum of potential difference across the individual resistors.
Now first we understood that this battery was generating 6 volts of potential difference. We have left 6 volts. But if you see voltmeter reading through resistance 1, resistance 2, resistance 3 separately, if you see, think this is 1 volt, this is 2 volt, this will be 3 volt. Add it and see, 1 plus 2, 3 plus 3, 6 volts. So total if you do, you will get 6 volts. Or if you connect, this is X point, this is Y point, all three are connected in series. If you take it here, how much will be this? 6 volts. Getting? How much you will leave, that much only you will get. 6 volts will leave, you will get 6 volts back. But how you will get, that is different. If you take XY connection like this, if you connect them in series, get like this, you will get 6 volts. If you keep 3 different voltmeters, one separate, one separate, one separate. How many voltmeters are there here? First voltmeter, second voltmeter, third voltmeter. Separate he has connected. Separate connection for each resistance. R1, R2, R3. For each resistors, separately he has connected. If you add the sum of V1 plus V2 plus V3, you will get what? The total V. So only the formula V, if it is 6 volts, then V1 is 1 volt, V2 is 2 volt, V3 is 3 volt. So 6 volt will be equal to 6 volts. That's the formula now. So in series, the potential difference V is equal to V1 plus V2 plus V3. Any doubts how we got that formula? Is it simple? Direct connect ಮಾಡಿದ್ರಿ will get direct 6 volts. ಈಗ ಒಂದೊಂದಕ್ಕೆ ನಾ ಈ ಟೈಪ್ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ಕೆಂಪ ಇಲ್ಲಿ ಒಂದು V1 ಮತ್ತೆ ಇಲ್ಲಿ V2 ಇಲ್ಲಿ V3 ಹಿಂಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ಇವೆಲ್ಲ ಆಡ್ ಮಾಡಬೇಕು. If you add that, we will get back same. Any doubts? Any doubts? Okay. One more example I can give. Take notepad, escape. When ನಿಧಿ ಮಾಡಾಕತ್ಬಿಟ್ಟೇನು notepad. ಲಾಸ್ಟ್ ಇಯರ್ ಒಬ್ಬ ಇದ್ದಾವ ನಿಧಿ ಮಾಡಾಕತ್ಬಿಡ್ತಿದ್ದ ಅವ್ನಿಗೆ ಎಬಿಸಿ ಕುಂದಿರ್ಸ್ಬೇಕಾಗಿ notepad. ಇಲ್ಲಿ ನೋಡಿ ಸರ್ಚ್ notepad, NOT. ಇದು ಲೋಡ್ ಮಾಡೋದು ಅದೊಂದು plus. Okay, now see here, if I'm giving 10 volts, think 10 volts I'm leaving, there is a connection. Okay, I'm doing very basic diagram. Ammeter 1, 2 yada togonu. Okay, only 2 are there. How much I'm giving? 10 volts. If I take, this is first resistance R1, this is second resistance R2. If I connect it like this, XY, and if I pull out the plug and keep my voltmeter here, how much will I get? Directly 10 volts I will get. Output. Hing vadapanan or na hing connect ಮಾಡ್ತೇನೆ. Same. Okay, ammeter here, battery here. I will connect like this. First R1, R2, R1, R2. Here 1 voltmeter I will add, V1. Here 1 voltmeter, V2. This can, if this is 3 volt, this will be how much? Definitely 7. So V is equal to V1 plus V2. 10 volt is equal to 3 volt plus 7 volt. 10 volt is equal to 10 volt. 2 connections are there. If you do this connection, direct answer will get. If you do this connection, you should add. So we have arrived on formula. The formula is V is equal to V1 plus V2 plus V3 in series. But this parallel will work. We don't know what parallel in series. Any doubts? Okay, go back. ಅದು ಇದನ್ನ ಮಾಡಬೇಡಿ. ಅಷ್ಟ ಮಾಡು, ಸ್ಲೈಡ್ ಶೋ. Next. Read.
Let the current through the electrical The three resistors can be replaced by an equivalent similar resistors or resistance R such that the potential difference and the current remains the same. Applying the Ohm's law to the entire circuit, V is equals to IR. Applying the Ohm's law to the three resistors separately, V1 is equals to IR1.
Okay, see, this is the most important now. Just now we have arrived on formula V is equal to V1 plus V2 plus V3. Correct? What was Ohm's law? Ohm's law, if you remember, it was V is equal to IR. Ohm's law, V is equal to IR. Then by the Ohm's law, potential difference is equal to current into resistance. Current is equal to potential difference by resistance. I is equal to V by R or V is equal to IR. This is the Ohm's law. Now V is equal to IR, okay, it's perfect, but we have three resistance here. Resistance 1, resistance 2, resistance 3. And each resistance has different voltages. Just now we saw that. Each resistance holds different voltages. So, first V1 I can write as IR1. V1, the potential difference through this V1 I can write as IR1. And the potential difference to V2 is IR2. Potential difference in V3 is IR3. If I go by Ohm's law, here it is V, I can take IR. We can take direct IR. But here, this is IR1, IR2, IR3. Because of the resistance 1, 2 and 3, all three will have different voltages in them. So, V is equal to IR1 plus IR2 plus IR3. Is this correct? Why I am not writing I1, I2, I3? Think. Why I am not writing I1, I2, I3? I am writing R1, R2, R3 because voltages are differing. But I am not writing I1, I2, I3. Why? Why? Huh? I am writing R1, R2, R3 here. R1, R2, R3. Because voltage is different in this, voltage is different in this, voltage is different in that. Correct? But why I am not writing I1, I2, I3? Because it is series. In series connection, current through every resistance, current through the whole circuit will be same. So current is I, constant, 5 ampere and 5 ampere, 5 ampere, 5 ampere. Getting or no? But resistance value can change. Resistance value can change. Resistance ಹೆಚ್ಚು ಕಮ್ಮಿ ಇರಬಹುದು. ಇದು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರಬಹುದು, ಇದು ಕಮ್ಮಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರಬಹುದು, ಇದು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇರಬಹುದು. Resistance, it's based upon me. How much I want, I can keep resistance. But the current we cannot change. Throughout the circuit, it will be one same. Getting? So the formula goes as IR1 plus IR2 plus IR3. So IR is equal to V is equal to, this is V, V is IR, is equal to IR1 plus IR2 plus IR3 according to Ohm's law. Ohm's law. Getting? And RS is equal to, RS means resistance, is equal to R1 plus R2 plus R3. So this is the most important. RS means total resistance. Total resistance is equal to, think this is 5 ohm, 2 ohm, 3 ohm. How much is the total resistance? 10 ohm. In series, we will add R1 plus R2 plus R3 is equal to RS, total resistance. And if I take voltage, the formula goes as V1 plus V2 plus V3, where V1 means IR1 plus IR2 plus. One simple example I will take. Here I have written here. Okay. Current we will take it as 5 ampere. 5 ampere pass agate anta vichar madri. So I is how much here? 5. R1 ಎಷ್ಟಿದೆ? R2, R3, 25, 10, 15, 40, 30, 40, 50. Total V will be 50. Total voltage in that circuit will be 50. Not equal. So two formulas. V is equal to V1 plus V2 plus V3, R1 plus R2 plus R3. Second formula, resistance is equal to R1 plus R2 plus R3. Any doubts? Okay. Now take notepad back. This moves good. Notepad open ಮಾಡಿ. Okay, see here. So if I take a series resistance, okay, if we take a series resistance, this is R1, R2, R3. These all are connected in series, you can see them. So if I need to find RS, the total resistance is one more question. This has appeared for board. Okay. This is 6. Huh? How much is the total resistance in this circuit? Total resistance in the circuit. Yes, I think total resistance. Mithali, total resistance in the circuit. Help, total resistance in the circuit. Total resistance. And rest some kelatir and tirade. Imran. How? So I said that we should add R1 plus R2 plus R3. RS is equal to R1 sit plus R2 plus R3. R1 is how much?